In order to start using the expansion of minors method to evaluate a 3x3 determinant, we need to develop the notion of the definition of a minor. So it says here that the minor of an element in a 3x3 determinant is the 2x2 determinant that is obtained by eliminating the row and column which contain the element. So in practice, for example, let's say we had the the determinant A1, A2, A3, B1, B2, B3 as the second column, C1, C2, C3 as the third column. Now there are 3 rows and 3 columns, so it's a 3x3 matrix or a 3x3 determinant. So, as it said, the minor of an element is obtained by eliminating the row and column that contain the element. So let's say I wanted to find the minor of A1. So A1 is here. So what we want to do is get rid of the row and the column which contain the element and write down the 2x2 matrix that's left over. So in particular, the minor of A1 is the 2x2 determinant B2, B3 as one column, and then C2, C3 is the other column. Right? So not so bad. So let's try a different example. So let's say I wanted to find the minor of B2. So again, we find B2, and then we get rid of the row that it's in, and we get rid of the column that it's in, and we write down the 2x2 determinant that's left over. So the 4 entries left over are A1, A3, C1, C3, and you write them in the order in which they appear on the 3x3 determinant. So that's the minor of B2. So let's do one more. Finally, if, for example, I want you to evaluate the minor of C3, again, what you do is you look for C3, and you get rid of the row that it's in, and you get rid of the column that it's in, and you write down the last 4 entries. So the minor of C3 in this case is going to be A1, A2 in one column, and then B1 and B2 in the other column.